Alright, we're going to be moving on to nth roots here, section 6-4. So, we're going to start off with just square roots, just so we can get the idea here of what happens with nth roots. We know 8 squared is 64, so the square root of 64 is 8. Same thing with 5 squared. We know 5 squared is equal to 25, so the square root of 25 is equal to 5. Taking this idea one step further, what about x to the square root of x to the fourth? Well, it's got to be something squared has to equal x to the fourth. What's that going to be? And we can look at this as, well, x squared. Squared is x to the fourth. Because that would be x squared times x squared, which would give me x to the fourth. Most of these problems are just figuring out another way to rewrite it that you can solve, that makes sense to you. So the square root of x to the fourth is just x squared. Same thing as this one, the square root of x to the sixth. Well, the square root of x to the sixth is going to be x to the third, because x to the third squared is equal to x to the sixth. If I were to write this twice, x to the third times x to the third, multiplying it by itself, I would get x to the sixth. Now, if you don't understand this way, there's other ways we can rewrite it. We know that the square root of x squared times the square root of x squared is the same thing as x to the fourth. And the square root of x squared is just x. The square root of x squared is just x, which would give me x squared. Do the same thing down here. X squared times the square root of x squared times the square root of x squared. Give me x times x times x, which is x to the third. However you need to rewrite it, you should arrive at the same answer though. Now, what if we have a different root though? What if we don't have a square root? Well, these are all square roots. We don't write it up here, but there's a 2 there, because it's undoing something to the second power. So what if we had a third root, or a cubic root? What is the cubic root of 125? Well, the cubic root of 125 is going to be 5, because 5 cubed is equal to 125. If I needed to, I could rewrite this. 5 times 5 times 5, which is the cubic root of 5 cubed. And if I'm taking the cubic root of something cubed, that should just give me whatever that number was. Same thing on this one. 81. What if I had to find the fourth root of that? Well, I could break this down into 9 times 9, or I could break those down into 3 times 3 times 3. So what is the fourth root of 3 times 3 times 3? Times 3. The fourth root of 3 to the fourth should just be 3. Because 3 to the fourth is equal to 81. So we're just undoing it here. So the fourth root of 81 is equal to 3. If I give you the fifth root of 32, pause the video, try to find the fifth root of 32 on your own. I could rewrite this 2 times 2 times 2 times 2 times 2, which would be 2 to the fifth. So the fifth root of 32 is going to be 2, because 2 to the fifth is equal to 32. So we're just going backwards here with nth roots. Switching up a little bit, what if I said take the third root of x cubed y to the 12th? Well, I can break this up here into what's the cubic root of x cubed, and what is the cubic root of y to the 12th. Well, I'm going to split this up even a little bit farther here. This one obviously is just going to give me x. But what times itself 3 times is going to give me y to the 12th? Well, let me see here. Y to the 4th times y to the 4th times y to the 4th. This is the same thing as y to the 4th cubed. So those would cancel out right there. And I would just get x, y to the 4th. So that's how you work these. Now, another way you can look at these. This is a little bit out of sequence from what our book does, but I think it's going to be easier for you to work with here. I can rewrite the square root of x as x to the 1/2. Square root, I could rewrite the square root of 9 as 9 to the 1/2 power. I could rewrite the square root of 16 as 16 to the 1/2 power. If you decide to do this, go ahead and try in your calculator. Take 9, raise it to the 1/2 power, or raise it to the 0.5. If you do, you'll find the answer is going to be 3. And if you take 16 to the 1/2 power, you'll find the answer is going to be 4. So what you can do with these then is, if I get something like this problem up here, I can rewrite this. X to the 3rd, y to the 12th, in parentheses. Instead of the to the 1/2 power, this is going to be to the 1/3 power. Now, I can use my properties of exponents and just distribute that. 3 times 1/3 is just going to be x to the 1. 12 times 1/3 is going to be y to the 4th. And I get the exact same answer. If I came back up here and did the same thing, x to the 4th, had to take the square root of this. I could rewrite this as x to the 4th, all raised to the 1/2. And if I multiply those right there, that's going to give me 4 times 1/2 is going to give me x squared. Square root of x to the 6th. I can rewrite this as x to the 6th raised to the 1/2. That would give me x cubed when I multiply those. Oops, sorry about that. So that's another way you can rewrite these. Giving you a slightly different problem here. One more example here. If I gave you 8y to the 6th and said find the cubic root of this. Well, I'm going to break it up into the cubic root of 8 and the cubic root of y to the 6th. Well, y to the 6th can be rewritten as y to the 2nd to the 3rd, because y squared times y squared times y squared is going to give me y to the 6th. And that's cubed, so my final answer is going to be y squared. 8, well, 8 can be written as 2 cubed. 2 times 2 times 2, 2 cubed. So the cubic root of 2 cubed is just going to be 2. So 2y squared is my final answer. And if I'd want to do this using the exponents as fractions, I could do that as well. 2, I'm still going to rewrite it though. 2 to the 3rd and y to the 6th, all to the 1/3 power though. I can distribute that just like that, and I'm going to get the same thing. All right, couple of weird examples here. It is possible to have a binomial inside of a square root. That's okay. Don't think I have to take this to the fourth and this to the fourth, because we know we can only do that if it's multiplied in between. So I'm going to break this up into the square root of 4 times the square root of x minus 2 to the fourth. And square root of 4, of course, is just 2. And if I rewrite this, it's x minus 2, squared, because 2 times 2 would give me 4. So if I take the square root of that, those cancel out, it's just going to be x minus 2 squared. Now, if you don't understand how that worked, let's rewrite it a different way. We just rewrite square root of 4 times x minus 2 squared, x minus 2 squared. Well, those are both squared, so that means it would be x to the fourth there. So this is going to be 4 times x minus 2 times x minus 2, which gives me 2. Square root of 4 is 2, x minus 2 squared. So don't freak out if there's a binomial in there. Don't think, actually, we don't have to go ahead and square this. We can just leave it just like that. Sometimes that is the simplest way to deal with it. Now, this next part's kind of strange at first glance, but if you think about it mathematically, it makes sense. I'm going to split this up into square root of x squared and square root of y to the fourth. So this is a square root of x squared, which is just going to be x. Square root of y to the fourth, well, I can rewrite this as y squared times y squared. And that's just going to give me y squared. But I'm not done, actually. See, x could be a negative number. X could be negative 5. But square roots only give us positive numbers, unless there's a negative in front. Remember that from our graphs. They only go up like this. So, to make this positive, I have to put an absolute value around it. You only have to do this if the root is an even root. You don't have to do this if it's an odd root. If n is even and the root is odd, like it was here, this was x to the first, then put absolute values around the root. Once again, we only do this because square roots or fourth roots only give us positive answers. And in our last example here, even though we can never take the square root of a negative number, we can take the cubic root of a negative number for the simple reason that of the following. Negative 3 to the third power is in fact negative 27. So negative 3 to the third power and then x to the fifth cubed. If I take the cubic root of both of those, cubic root there cancels out, and that one cancels out, so we're going to get negative 3x to the fifth. So if it's an even root, you have to put absolute values around it. If the square root is odd or the fourth root is odd, whatever it is. But if it's an odd root, doesn't matter what it is, and it's if it's negative in here, you can still take the root of it, just because a negative number raised an n number of times, if it's odd, will in fact be negative. So a lot of these are just going to take a lot of practice. I've got quiz trade cards you can work with, but just keep practicing, work it over and over again. Try to find different ways you can write it. Thanks for watching.